Bismillahir Rahmanir Rahim. Hello, guys. Hello, class everywhere. This is our eighth episode on chemistry. We are moving towards chapter 5. However, we have two topics we borrowed from chapter 4 in order to complete the picture for core and supplement students who will take their exam on 2023 through 2025. The core has three main topics in relative masses of atom and molecules. Those are describe relative atomic mass AR as the average mass of isotopes of an element compared to 1/12 the mass of an atom of carbon 12. Define relative molecular mass as the sum of the relative atomic masses, relative formula masses, MR, will be used for ionic compounds. The first portion, the relative atomic mass, we finish it and we make a lot of calculations and solve a lot of problems in the previous episode. And in this episode, we are going to deal with the MR, which is the relative molecular mass at the sum of the relative atomic mass, relative formula mass, MR, and this will be in ionic compounds. We are going to take this today on this episode. Then the next episode, we are going to calculate reacting masses in simple proportions. Calculations will not involve the mole concept. All this part is for actually we borrow it from chapter 4, the last portion of chapter 4, in order to have a good background to move towards the mole concept in chapter 5. Let us start. In our previous episode or lecture, we have the relative masses or the relative atomic mass for isotopes. And we said that a relative atomic mass is the average weighted mass of an atom of an element compared to 1/12 the mass of the carbon 12 atom. And we differentiate between the regular arithmetic average and the weighted average, how everyone is different from the other, and the weighted average always having in consideration the contribution of the thing in its statistical community. Today we are going to study the relative molecular mass, and we will have a lot of examples and solve a lot of problems to be acquainted of how we can solve problems of this part. However, the definition of the relative molecular mass, and the symbol of it is MR, A relative molecular mass is the average weighted mass of a molecular of an element or a compound compared to 1/12 the mass of the carbon 12 atom. Neither in atomic relative atomic mass nor in relative molecular mass we will take in consideration the mole concept. We will leave the mole concept when we come into uh, chapter 5. We are still in chapter 4. Yes, the title is chapter 5, but we borrowed this from chapter 4 in order to have a solid ground so we can move forward without hesitation. Let us go and see what we have and how we can deal with the calculation of the relative molecular mass. In order to come out with the proper calculation for the relative molecular mass of a molecule, we have to follow the steps below. The first thing is to determine each atom in such molecule. Second is to determine the quantity, the number of each atom. How many atoms of the element X is sharing the composition of such molecule. Number 3 is to determine the atomic mass of each atom, either given in the problem or from the periodic table. If they are not appear in the problem, I have to go and seek for them or look for them in the periodic table. Then after I bring this one and I bring this one, I multiply each quantity. That means number, how many of each, by its corresponding mass. Then sum, that means add them together using the appropriate equation below. Let us go downwards and see what equation and how we can deal with this. The proper equation or the appropriate equation used to calculate the regular molecular mass is like the following equation. Relative molecular mass, MR, equal big parenthesis the number of atom 1 in the molecule, the number, how many atom 1 present in this molecule, multiplied by the atom 1 mass plus number of atom 2 in the molecule multiplied by its mass. You see this one under two parentheses, small parentheses, and here also there. Then plus to infinity. That means if it has more than 2 atoms, this molecule has more than 2 atoms. I'm going to add the atom 3, the number of atoms 3 in the molecule multiplied by the atom 3 match, the number of atom 4 in the molecule multiplied by atom 4 mass, and so on. This is the appropriate formula. I will use it for in case of I need to calculate the relative molecular mass. Now, we will start solving some problems, and by repeating them, we have about 10 problems, and by repeating the solution of each one, we will fix the way that we are going to solve these problems. First, problem says calculate the relative molecular mass of the following compound C4H11N given, that means some information are given to you, relative atomic mass of carbon equal 12, relative atomic mass of hydrogen equal 1, and relative atomic mass of nitrogen equal 14. Solution. In the solution, we are going to follow the instructions that I have given to you. So I've given you a lot of information, about 5 information, and we would like to utilize this information in order to have the solution of this problem. Number 1, atoms which composed the molecule are C, which is carbon, H, which is hydrogen, N, which is nitrogen. And this is the first statement or first item you have to search, is to determine the atoms that shares the molecule. Now, quantities. We would like now to know how many of each atom is present in such molecule. So here we have C4, so we have 4 carbon atoms, H11, and this is 11 hydrogen atom, and only N, that means 1 nitrogen. Okay, now the third step is to determine the relative atomic mass of each atom. Okay, so this is already given in the problem. In the problem, they said to us that the relative atomic mass of carbon is 12, a relative atomic mass of hydrogen is 1, and relative atomic mass of nitrogen is 14. So it is already given in the problem. Now I'm going to use the appropriate equation, which says relative molecular mass, Mr, equal the number of atom 1 in the molecule multiplied by atom 1 mass plus the number of atom 2 in the molecule multiplied by the atom mass, atom 2 mass, and so on. So if we put it here, the relative atomic mass of the CH4H11N is or equal to 4 atoms of carbon multiplied by its mass, 12 here, and then 11 hydrogen atom multiplied by its mass, and also there is only 1 N multiplied by its mass. And when you do the mass of all these and sum them together, it's gonna be 34. Put in consideration that this compound has a covalent bond. It is not ionic bond. So we say relative, we name it relative molecular mass. And we will see when we change this bond into ionic bond, is it still being relative molecular mass or something else? Let us go forward. In problem 2, we have something to do in repetition, and we have something new. So we have to know what is going on. Now, here is the problem 2. Calculate the relative formula mass, not molecular mass. So why there is a change? Let us go forward, then I will answer this question. Of magnesium hydroxide, and still there is the given information that the relative atomic mass of magnesium is 24.3, relative atomic mass of oxygen is 16, and relative atomic mass of hydrogen is 1. So why he used the word relative formula mass? This is because this is an ionic compound. There is a metal here, and there is an ionic compound, and because the ionic bonds needs some sort of formula unit rather than molecular structure, we take it as a relative formula mass. That this is the only difference here present, but we have to go through our procedure, the same procedure. First, to determine the atoms which compose the molecules, which are magnesium, oxygen, and hydrogen. Then the quantities, that means how many atoms of each of these ones shared in this compound. Magnesium is 1, oxygen is 2, hydrogen is 2. The question is why? Why they are 2? Because they are between two parentheses, and there is a 2 here. That means I have 2 OH. It should be magnesium OH, OH. So in order, we just take it into parentheses and put 2 here, indicating that those are more than only 1 O and 1 H. So they are 2 because I'm going to multiply this by 1. It's going to be 2 oxygen, and then multiply this by this is going to be 2 hydrogen. This is the answer of why. Relative atomic mass of each element is given actually here. The appropriate equation used is the relative formula mass. We change it from the relative molecular mass into the formula formula mass, which is the number of atom 1 in the molecule, means how many of atom 1 is in the molecule multiplied by the atom 1 mass and plus number of atom 2 in the molecule, means how many of atom 2 present in the molecule multiplied by its mass, and so on. And here, because we have 3, here we have 3. 1 multiplied by 2, 4.3, and 2 multiplied by 16, and 2 multiplied by the 1. When you do the mass of each multiplication, then add them together, all it's going to be 58.3. Please do the math and let us know if there is any problem or we are wrong in a place or not. This is the second one. Let us go for the third one. Coming to the next problem, which is problem number 3. Yes, problem number 3. Calculate the relative formula mass of sulfur oxide, SO2, given. We have the given marks, and we just simply would like to do the same mass as before. Again, it is just by repetition. we are going to deal with the same steps that I have already talked about it before, regardless of how many or how long this molecule is. So it is now the first thing is to determine the atoms. It is S and O. To the quantities of the atoms, it is 1s and 2o. That means one atom of sulfur and 2 atoms of oxygen. Relative atomic mass is given in the above. So this is O is 16 and the sulfur is 32.7. Relative atomic mass of each element is given. Appropriate equation is the number of atom 1 in a molecule. That means how many multiplied by the atom mass, the amount of mass, number of atom 2 in the molecule, how many atom 2 in molecule, multiplied by it is mass, and so on. And here, because we have only 2, so we just do the equation, the compensate. Atom 1 is only 1, the number is only 1, how many is only 1, and then this is the mass of it, plus the how many of atom 2 is just 2 oxygen atoms, multiplied by 16, which is the mass of oxygen. And when you do this mass and this mass, this multiplication masses, so you and add them together, the total is going to be 64.07. Very simple. You just put the steps and follow the steps one by one. You will be bro after doing all these exercises. You are going to be number 1 in solving those types of chemical mass. Before we enter or try to solve problem 4, I would like to remind you that our protocol consists of 5 steps. You have to know those 5 steps, follow them one by one without skipping any step, and you will be pro in solving such types of problems. Now, our problem 5 is calculate the relative molecular mass. We didn't say formula mass. We say molecular mass of the following compound, C3H8O. Why we do that? Because this is a covalent bond molecule. Now, here we have something else. The problem says use the relative molecular mass of each atom. Sorry. So use the relative atomic mass of each atom of each element as it appears in the periodic table. So here we are going to borrow the periodic table, pick up our atoms and pick their relative atomic mass. Now, what are the atoms that share this molecule? Atoms which compose the molecule are C, carbon atom, hydrogen atom, and oxygen atom. Now, how many of each atom is 3 carbon, C3, 8 hydrogen, H8, and 1 oxygen atom, 1 oxygen atom. Now, the relative atomic mass of each atom or each element, I'm going to search on the periodic table and see how many the amount of each one, how much it weighs in each one. So in the periodic table, I see that the carbon atom is 12.01. The relative atomic mass of hydrogen is 1.01, and the relative atomic mass of oxygen is 16. Now we do the calculation by choosing the appropriate equation. The same equation, number of atom 1 in the molecule multiplied by the atom 1 mass plus the number of atom 2 molecule of the in the molecule multiplied by its mass, and so on till the end. And when we do it here, we do the same calculation. 3, which is here, multiplied by the mass, which is here. The 8, which is here, the number, or the how many, multiplied by the mass, which is here. And then the number, which is here, how many, and then how much it's weighing is 60. And then when I do the mass of each of the 3 multiplications and then add them together, the result is going to be 60.11. As I told you, follow our protocol. Follow our protocols. Our protocol is formed of 5 steps. 5 steps. 1, 2, 3, 4, and then the calculation, which is 5. You will be a bro, I promise. Here we are going to use or to solve another problem, but there is a little trick I would like you to pay attention for it, because if you know it from the beginning, you are going to observe it all the time it comes. If not, you are going to fail recognizing it, and if you fail to recognize it, you are going to do it wrong or to solve the problem wrong. Now, what is the problem? The problem says calculate the relative formula mass, and whenever you have formula, that means you just put in mind that the coming compound is an ionic compound. Mass of calcium nitrate, which is calcium nitrate, calcium Ca, 2 parentheses, N, which is nitrogen, O, which is oxygen, 3, 2 parentheses, and there is the red 2 here. And this is very, very important. Be careful and see how we can get rid of this hazard. There is another information says that use the relative atomic mass of each atom of each element as it appears in the periodic table. It's okay. Now, let us go. First, we have a protocol of 5 steps. 5 steps. First, we are going to apply this protocol. Step 1 says, what are the atoms that form the molecules? It is calcium, nitrogen, and oxygen. That's it. The second is how many. How many of each of them present in the compound or the molecule? So I have only 1 calcium atom. So 1 calcium. I have N. Is it 1? No. This group, which is NO3, the nitrite group is actually multiplied by 2 because there is a parenthesis here. And that means it is not calcium NO3, it is calcium NO3 NO3. It is this way. So I'm going to multiply this by the inside. So from out to inside, 2 multiplied by N equal to N, and 2 multiplied by 3O equals 6O, or 6 oxygen atom. And this is the answer of why this is 2 and why oxygen is 6. Now I determine those 2 things. The last thing is to determine the relative atomic mass of each element, atom, and it is like this here. I bring those from the periodic table. Then you have to put the relative molecular mass appropriate equation, and it is the number of atom 1 in a molecule multiplied by its mass plus the number of atom 2 in the molecule multiplied by its mass, and so on. And when we do that, the mass is going to be 1 for the calcium atom multiplied by 40, which is the mass, 2 for the nitrogen and multiplied by its mass, 6 for the oxygen multiplied by its mass. And when you do this, it's going to be 164 multiply 0.1. So be careful of having those type of problem here. Be careful of this red flag. Another trick in problem number 6. Very small trick, but you have to pay attention to it in order to solve it. Apply the protocol and you are going to get the right answer for each one. Now, calculate the relative, this is what it says. Calculate the relative formula mass of ammonia phosphate. This is the molecular unit of ammonium phosphate, which is NH4 3PO4. Use the relative atomic mass of each one as it appears in the periodic table. So we have the same problem as the previous one. The difference is that instead of the group become number 2, no, it is now number 1. The group is number 1, and then after that there is the second group. Again, when they say the formula, that means we are talking about an ionic form. Now, let us go for this. Atoms which compose the molecule are nitrogen, hydrogen, phosphorus, and oxygen. So I determine the atoms that are part of this molecule. Second, quantities. How many of each atom? So I have 3n because I'm going to multiply this 3 by 1n. It's going to be 3n, and this is the answer of why it is 3n. Now, the same thing I'm going to do for the hydrogen. This is 4 hydrogen atoms, so I'm going to multiply 3, the red 3, multiplied by the black 4. It's going to be 12H. And this is the answer of why this is 12. Then I have only 1 phosphorus, and then 4 oxygen atoms. Now I determine how many of each atom is sharing this compound. Now I'm going to look in the periodic table and bring on the table the relative atomic mass of each element, and it appears like this in the of each one. The new one is the phosphorus, which is 30.97. Then the relative atomic mass, as usual, it is the same formula that says number of atom 1 in a molecule plus multiplied by atom 1 mass, number of atom 2 plus number of atom 2 in the molecule multiplied by this mass, and so on. And then I'm going to make compensation of each one. 3 of the nitrogen multiplied by its mass, 14, I have 12 hydrogen atoms multiplied by its weight or mass, and then one atom of phosphorus multiplied by its weight, and four atom of oxygen multiplied by its weight, and then the calculation is going to be 149 plus. This is how you do it. You just put the protocol in front of your eyes, in front of the paper, in front of your memory, and then apply it step by step. You are going to be pro. Now, this is number 7. I would like to pay attention more than you did when you try to understand the previous 6 equation, because here we have an abundance of addition of molecules which are part of a big molecules, and this sometimes makes some problems. So let us go for our 7th problem. It says that calculate the relative formula mass of the following compound. I don't care about this compound. This compound is called hydrate compound. What I'm care about is how to solve the problem. And then after that, when it comes a time that you are going to know how this comes, from where this type of compounds come from. Now, it is magnesium sulfate hydrate. This is a hydrate, or hydrated magnesium sulfate. This is formed of many items. Let us go for here. We have magnesium. We have, doing our protocol, we have sulfur. We have oxygen. And we have hydrogen, and then we have another oxygen. What we are going to do, we are going to add this oxygen to this oxygen. So we are going to work with them as one, because oxygen is oxygen, regardless of whether it is present in the end or in the middle. Now, after determining, using our protocol, determining the type of atoms, then the quantity, how many atom that shares. Now, I have one magnesium ion, magnesium atom, and also I have one sulfur, but I have 14 hydrogen. From where it comes? From these 7 hydrogen water molecules, H2O molecules. So I'm gonna multiply 2 by 7. It's gonna be 14, and this is the answer of Y. And then I have 11 oxygen. Why I have 11 oxygen? Because 7 multiplied by 1 equals 7 oxygen atoms, plus 4 here. The total is 11. So this is the answer of why it is 11. Then after that, I'm going to look on through the periodic table and pick the relative atomic mass of each one. After that, I will choose the appropriate equation, which is the number of atom 1 in molecule multiplied by the atom mass plus the number of atom 2 on the molecule multiplied by its mass, and so on. And then we try to solve the problem like this, just by compensation. 1 multiplied by 2, 4.31, and 1 multiplied by 32, and then 14 multiplied by 1, and 11 multiplied by 6, doing all these things together, and then at the end I'm going to reach this answer. This is the result. So now what I want you to do is, do not panic. Just memorize or the protocol in order, and then you go through protocol till the end, and you are going to be the bra of chemistry. Um, Problem number 8 is very simple and very direct because it has only very direct compound. Calculate the relative molecular mass or formula mass of magnesium chloride. Magnesium chloride is here, is MgCl2. Using the following. Here, he gave us the each atom uh, relative atomic mass. Do not say that, no, I know that the magnesium is for is 24 point something. No, just use what he gave you. Since this is a given information, do not hesitate. It is, you have to go through this. Then you apply your protocol. You have a protocol of 5 steps. You apply the protocol and then you end with 1 multiplied by 24 e plus 2 multiplied by 35.5. Both of them, when you do the math, it's going to be 95. Very simple, very direct. Problem number 9 is also easy. The only difference that it's composed of 3 atoms. Just you have to calculate the relative formula mass of sulfuric acid, which is H2SO4. Again, the problems gives us the atomic mass of each one. So do not go and say, no, I know that this is not the rate. Just you have your protocol, go through the protocol, all of it, and then make the compensation, the proper compensation in order. And after that, you add them together, it's going to be 98. Number 10 is also an easy one. Just a compensation if you follow the protocol. And it is about the relative mass of sodium carbonate, which is here is the sodium carbonate, using the following relative masses. So it gives you the relative masses. You just follow the 5 steps protocol, and then you compensate each one by the number and the mass, and then the number and the mass, and then the number and the mass. You do the multiplication mass first, and then you add them together, and you come with 106 as the relative formula mass of sodium carbonate. We say formula, that means this one, this is this compound is an ionic bond compound. So we would like you to deal with this by using our protocol, which is the 5 steps protocol, and you are going to be the bra in chemistry. Now we come to the end of our episode. I hope everything goes as you like, and I hope you understand now how you can get the relative atomic mass of the isotopes, and also how you are going, you will do the relative molecular mass or relative formula mass of any compound. Just the 5-step protocol in each, and you are going to be the pro in chemistry. Be careful. These are we bring it from chapter 4 in order to make a good background for us. Now, thank you for having me, and I appreciate your patience. Just follow me. If you have anything, just do it in the write me a comment down in the comment section. Thank you and have a good day.